All right, good afternoon, everybody. Thank you for attending this presentation about AV1, the future of video compression here within the security industry. If you don't know me, my name is Steve Burdett. I work for Axis Communications as the manager of the solutions management team, getting to work with a lot of the cool technologies that we are rolling out this year and at this trade show. AV1 is one of the big things we're excited to talk about, particularly on what it's going to do for the industry and for compression as a whole. So it's important to start by setting the stage of why is AV1 really important, and to do so we need to talk about what are the users trying to achieve with this technology. Well, generally the market that we're in right now is increasing the amount of data that they're trying to use, whether this is in higher resolution, this is in metadata for analytics, and or the different IoT devices that you have running into these systems that are more complex solutions than they are just a standard security or surveillance application. On top of that, you're running into a lot more analytics, meaning we're needing to run things into the cloud, across the bandwidth or the network maybe multiple times, and then there's a larger use of security devices, or what were formerly security devices. A lot more of them are being used now for business intelligence or operational efficiency purposes, all meaning that the strain on your networks and where your networks are extending to, maybe beyond just your local area to the cloud or above, is what is kind of leading the reason for AV1 and why we want to have this. So if we go, so the challenges they're facing should be pretty obvious based on that, on the things that they're trying to do. The bandwidth of the network is foremost the biggest limitation, right? Do I have to scale up the switches that I'm using, the cabling that I'm using, and or other, because obviously too much data running across those networks can create clogs. The cost then, if I have to update the cabling or the infrastructure or whatever it might be to make sure that I don't have those clogs, because those clogs are unacceptable. The higher video quality people are anticipating you wouldn't want to throttle if you were to have to make it fit into the network. So it wouldn't make sense to buy a 4K camera and only use 2 megapixels worth of the resolution. And you want that higher video quality, and you want to retain it at all costs for the analytics and or other data that you might be using to search, or other ways you might be searching into that data. And all this comes with demands on greater resources that could be used elsewhere. If I'm investing money in updating my infrastructure, I'm not investing that money somewhere else. And so this is basically the story of compression that we've heard for a long time, with this being the next generation of why it is, of what compression is coming to. So what is AV1? AV1 is a very open standard. It was actually developed by the companies you see here on this list. It's actually started specifically by Google, and they said, we want this to be open and available for everybody. So as a result, they made it free and open source, and they worked with some of these other partners, much like OnVIF is and within this industry. A lot of people coming together saying, how do we make this better so that it's good for the whole? Because compression isn't something that should be proprietary. It's something that should be available to all so that everything can be streamed and stored where it needs to be, not based on some codec restrictions or not. So formed by some of the biggest, smartest tech companies in the world, they said, we want to have a more brilliant compression codec. And so they came up with AV1. So most users, if you're going to be upgrading from H.264, this is a quote from our VP, Frederick Nielsen's here in the Americas, if you're going to be upgrading from the most commonly used codec in the industry today, which is H.264, you're going to see up to potentially greater than 40% savings in your bandwidth, whether that's through real time and or in storage. That compounding cost can be enormous. So the savings are real, and the savings are almost instant just by simply using a more efficient codec. This is the same story we told when we were using Motion JPEG and moving to H.264. This is now the successor of said story, because H.264 is, well, I guess I'll get to it, but it's about a 20-year-old technology. It wasn't designed for the world that we're living in today. So why it performs exceptionally well with high resolution? It was designed with high resolution in mind. As you saw with those company names, if you're using Netflix today, you're using AV1, and you probably don't want to be looking at it in 720. You're probably looking at it in 4K. You want the highest resolution. The free and open source is really important because it makes it so simple to adopt that anybody can go download the SDKs and put it into their software, so now they can stream AV1 as well, which means you're seeing it in all major browsers today. Most all computer operating systems support it, mobile platforms are supporting it, and then where it's taking more time to get into is the hardware acceleration in CPUs. In fact, that's what took it so long to get to this industry, is you have to build this onto the chip if you're going to be coding that way. It's a lot easier for a software to decode it by just putting in the SDKs. And this is optimized, no surprise, by the brands you saw just before, for cloud and streaming, meaning they cared a lot about that when they were designing how does this need to work and what does this need to work for. So if I talk a little bit about how this works, particularly in comparison to H.264, I want to be very clear. H.264 is a phenomenal technology. It's just old. So why don't we build on some of the capabilities? What you're looking at here is maybe one of the simplest way to visualize many of the complex things that it does. But if I'm looking at an image and I'm trying to figure out how do I compress, how do I analyze what I can compress, and how do I start to figure out where do I need to not compress, you break down the scene in what are called macro blocks. And AV1 had the ability to scale up, if you're talking about pixels, to a macro block size of 16 by 16. Not really great when a 4K has thousands upon millions of pixels, 2 megapixel being 2 million, 4K being 8 million. That's 4 times the amount that I need to analyze. And if I can only go up to groups of 16, that's a lot that I need to consider. AV1 can go up to 128, and it can go down to 2. So a 2 by 2 block to 128 by 128. This gives me the ability to, one, be less processor intensive, but also more intelligent on what sections do I want to compress more. If we look at this image, the back area that's maybe a bit blurry, there's no action going on. This is a good environment for the codec to do its work, but maybe where her hand is and or up against the reflection where there's fine details, this is where you don't want to compress. You want to make sure you maintain the utmost of quality. And these are principles that were introduced in H.264 that they are just building on with many other things on the back end, but building upon again in a newer version of the technology. So to see this in real time, we'll show you 2 video clips. They should be running about the same, but my clicking is not as quick as that. And in this case, you're seeing an H.264 video stream out of the exact same camera, an AV1 video stream. And we recorded them for 2 minutes, 4K, 30 frames a second, as you see here. And you're getting about 36% savings in this particular instant at this particular time. That's really helpful. Again, all variables are taken out. It's the exact same camera, one stream in one way, one stream another way. So this is to say, just on that principle alone, you're going to see good savings. What's really awesome and hard to show in a 2-minute video clip is what happens when this scene changes in the evening, where there's maybe less people that are moving, less activity that's going on. That's where AV1 starts to run away even more. So if you start looking at this over 24/7, 365, the compounding effect is enormous. This is a very tailored clip during a very specific scene where already we're seeing the savings. What happens when you look at that over the, as I said, the full day, the full year, and how much more it can run away with it. So very exciting in the proof there. So this, as I said, if we're looking at it just compared to the same self, we're seeing in some cases our averages that we're telling people it's about a 25% savings. I've just shown you a video where apples to apples, ARPEC 9 camera and AV1 versus H.264 was 39. So again, this kind of is subjective to your image and the video that you're looking at. But when you compare it to older versions, whether it's our ARPEC 8, which is the previous chip version, and or other chipsets that are out there that are maybe out there for 1 or 2 years or longer, the compression is that much better. Just because of the computation that you have, can even run H.264 more efficient on it, but still moving to a more modern technology in some ways gives you up to, as we're saying, 40% on average. That doesn't mean 40% as a maximum. It's 40% as an average is what we're seeing. So just those subsequent improvements in chipsets help, but certainly improvements in technology go that much further. So again, kind of talked a little bit about this, but why not H.264? This is an amazing technology. This has been transformative for our industry. It is simply just old. That's it. It is run its course. It's time to run to a new version. it did, the company or the organization rather that came out with H.264 came out with H.265, which is in all of our Axis or the most recent Axis cameras as well. So we are in support of this. It really comes down to adoption. H.265 has not been widely adopted within the industry, and really it's not about the way that codec works. It's a really good codec as well. The reason it's not widely adopted is they changed their license model and their fee structure that created confusion and a much higher cost. And those two things led people to not adopt it as widely. If you go to a web browser, you often have to go and download a very specific plugin to be able to run an H.265 decoder in it, because they don't want to roll it out in every single one, as those web browsers have to pay every time that it's being used. So it's not really about the technology, which is a shame. It's a great technology. It's just not widely adopted. AV1 being free doesn't really impact customers or people who are trying to use the products, but it demonstrates that it's that much easier for people to adopt, meaning that the exposure for it within the industry is going to be a lot easier to go wide. And particularly, this is a good example where it's already being widely adopted by some of the biggest names within the world, I guess. So it's to say it's not that it's not going to be adopted, it already is being adopted. It's a matter of just more widely adopted within our industry. So it also supports, as we mentioned, a lot for cloud integration. So this is built into a lot of cloud networks. We've already talked about it being built into your mobile phones as well. This is, as already discussed, founded by IT companies. This is optimized for protocols that are used in streaming, like WebRTC and other media profiles. And then the integration benefits tremendously, obviously, from the smaller data and transmission costs. If you're going to run something from an edge device, maybe up to the cloud, not only are you paying just for the transmission, but if you're going to store it up there, you're paying for that. So as much as you can optimize those costs, that's going to help keep your cloud costs down, your storage costs down, which is tremendous. So savings in bandwidth, savings in storage, transfer into savings in a lot more places as well. So that's why we think AV1 is the future of compression, and it is here today in our chipset. We know it's going to be widely used in the industry. Already we see multiple VMS at this show are integrating it as well, and it's widely integrated into many more browsers based. So beyond that, I'm here to answer any questions if people have any. I think we have a mic here. Cool. Awesome. Thank you so much for your time today.